right, let's walk through the last set of questions here. So for number 6, we have a table given to us. So in order to find the expected mean, we're going to go ahead and use our calculator, right? And we're going to go to Stat, Edit, and type in the x's into your L1 here, and then the probability of getting those outcomes into L2. So I've already done that. And then to calculate the expected value, we're going to quit out of here, go back to stats, go to calc, and we're in 2 variables since we have a list 1 and 2. And so for our x, you should have your L1, your y list should be L2. Super easy, hit calculate. And so you would find that the expected mean is 1.75. And the standard deviation is right here at 1.445. Okay, if you were to round. All right, and you do the same thing for the expected value of your y's for number 7 and the standard deviation of y. All right, and then in 8 asks us to calculate the sum of the expected values, in which case you'd take your a values and simply add them. Super easy, okay? But when it comes to standard deviation, you do not want to just add your b's together. It is not the standard deviation of x plus the standard deviation of y. Okay, that's a common mistake that's found. So instead, what you want to do is use our formula that you're supposed to have memorized, but which is take the square root of each of those squared after adding them. Okay, and it's kind of like Pythagorean theorem. A squared plus b squared equals your c squared, in which you take the square root. And so you guys can do that and check your answers. All right, number 9 is more what I want to spend my time on with you. So number 9 has cholesterol levels. We did the curve, which is super helpful in answering these questions. Otherwise, I'm not really sure how you would understand what's going on. So I filled out my normal, my frequency curve, and so they want to know the percent that fall between 192 and 244. And so since those lie on nice standard deviations, we know that that's within 1 standard deviation, which means 68% of our data lies within the cholesterol levels of 192 to 244. All right, so in part B, it asks for the cholesterol level of a male whose percentile score is 80. So because we know a percentile, right? So they want to know they're at the 80th percentile over here. What would this score be? So if you remember from our previous videos that in order to find the score, we're actually going to use our calculator and do the inverse option, which is number 3. And anytime you know a percentile, you're going to type that in. So in this case, it would be 0.8. And we're doing this to find our z-score. So when I type that in, I get my z-score 0.8416. So in order to find what the actual cholesterol level would be, you're going to use your z-score. That's always step 1, find your z-score. And then we're going to plug that into our formula. So if you remember, our formula is x minus mu over the standard deviation. So we're going to plug in our info here. And in order to find that, we know our mean is 218 and our standard deviation was 26. Okay, and then we'd cross multiply to solve, and you should get that the cholesterol level would be about 240. Okay, all right. So now to find the percentile of males who have a score less than 170. So what does that 170 represent? In this situation, it's not a percentile. Instead, it's a score, or the x. So they're giving us the x. So again, in every situation, you want to find the z-score first. So to find the z-score in this case, we're given our x. So I'm going to plug it in. 170 minus 218 divided by 26. And so we get our z-score to be negative 1.846. All right, we still have not actually found the percentile or the percent. So step 2, plug it into your calculator, right? Go to second vars, number 2, because I know my z-score. So I can type that in, negative 1.846 to calculate the percentile, right? And so our probability is 0.0324, and to find the percent, you could just multiply this by 100 to get the percent, which will also then tell us the percentile, right? Or move the decimal place. So 3.24%, which means that this person who has a cholesterol level of 170, should make sense here, 170, is in the 3rd percentile. Okay. All right. So now the last question. We need to find the percent who fall between 200 and 250. So if I look at the top, at the frequency curve here, here's 200 and here's 250. We want to know how many adult males score or have that those cholesterol levels. So in order to find that, what are we given? Well, what do 200 and 250 represent? They represent scores, right? So they're like our X's. So again, every single time, first things first, find the z-score. So go ahead and calculate the z-score on your own of each of them separately. So I'm going to do it up here, you do it on your own, and let's check. So you're plugging it into the formula. Maybe you're like, Mrs. Riley, you're a whiz. How'd you calculate that so fast? I'm pretty good. All right, just kidding. All right, so you got your z-scores. All right, that does not tell you the probability. So again, you're going to go to your calculator. Now, which button do you think you're going to use, 1 or 2, if you know the z-score? Correct. You guys are geniuses. You're going to go to number 2 and type in the upper, because we know the z-score is negative 0.6923, and calculate each of those probabilities separately. And so if you do that, you should get the probability here of 0.2444, and then the other probability, if you calculated that correctly, you would get 0.8908. And now always look back, you guys, to see if you actually answered the question. It says what percent who fall between, right? So that implies that you need an interval. So you're just going to go ahead and subtract those values. Okay. Type that in. I'm sorry, my iPad is jiggling around. My hand is getting quite tired from holding this. And so if you did that correctly, after you subtracted them, you would get the probability to be 0.6456. Actually, I lied. Hold on. Sorry, you guys. Yep. 6464. Okay. And so to find that percent, again, you're going to multiply by 100, and so you get the probability to be 64.64%. Okay, hopefully this helped, and now you guys are able to do worksheet 2 on your own. Good luck, you guys.